Welcome to the next installment in my video lecture series in economics. And in this particular video lecture, I'm going to be taking a look at the rationale for a transit subsidy. And in particular, this relates to my urban economics course, chapter 11, figure 11.2. So if we take a look at this graph, we have on the x-axis the ridership, and that's the number of riders. And on the y-axis, we have the cost per ride. We also have our demand curve, which is also the marginal benefit curve here in blue. It's downward sloping as normal. And additionally, I have an average cost curve and a marginal cost curve. So if this transit entity wanted to set pricing so that it had zero cost, it would set the price of a ride where average cost intersects the demand curve. Therefore, average cost would be equal to average revenue. The average cost would be equal to the price, and the costs and revenues would be equal, and this transit firm would generate no profit. So where average cost intersects demand is point A, that gives us our ridership of R apostrophe and the cost or the price of per journey of C apostrophe. However, the socially optimal output level is where marginal cost is equal to marginal benefit. So the marginal cost curve here where it intersects the marginal benefit curve. So that is point B, and that has a ridership of R asterisk and a cost of C asterisk. So the first thing I want you to realize that if this transit firm were to set price so it made no profits, it's not at the socially optimal level. The socially optimal level is going to be where marginal cost intersects marginal benefit. The problem with that is if we decide that we want to have the socially optimal level of output for the number of ridership, here R star with a cost of C star, the price is not going to cover the costs. As you can see here, at this level of ridership, this cost is not, the prices that are being charged per ride is not going to generate enough cost to cover average cost. So revenues are going to be less than average cost. So in order to achieve the socially optimal level of ridership, this firm is automatically going to lose money. So in order to compensate for this, that the rationale is in order to achieve the socially optimal ridership, this firm is going to lose money. However, there should be a subsidy provided to the firm providing this public transportation equivalent to what their losses are at the socially optimal level. So make sure you realize that what is the rationale. First, realize that if the transit firm or transit public corporation were to set price so that it made zero profit, this is the level of ridership that we would have, and be able to contrast that with what is the optimal level. The optimal level is where marginal cost intersects marginal benefit at this level here. But if we were to have the socially optimal level of ridership, this transit public corporation, let's say, would be losing money. So the rationale is that if we want to achieve the optimal ridership, the socially optimal ridership, we know that this firm is going to lose money. Therefore, in order to incentivize them to do so, we would provide, or the public would provide, the government would provide a subsidy equivalent to the losses at the socially optimal level of ridership.